Okay guys, today we're doing 5.2 linear approximation. Okay, so let's get started. Today we're going to be using a tangent line to approximate the value of a function. So let's say I start out with this function here. This is going to be my f of x, just like we were kind of talking about yesterday. And you now know how to write the equation of this red line, this tangent line, that touches this function f of x at one point, right? You use that y minus y1 equals mx minus x1. And then you go about solve for y, and you have a function for this line. What we're going to be doing today is it's very simple. We're going to be using that function that we create to estimate the value of f of x. So it's always going to be incorrect unless it's talking about the point that we actually figured it out at. So it looks like this one is a tangent line at about -1. So like let's say we created a function like this for this tangent line at -1, and it said use it to approximate at 0 to approximate the function f of x at 0. Well, you would plug in 0 into this function, and it's going to give you the value of 2. And that's going to be our approximation for f of x. Obviously, it's going to be incorrect because the tangent line is not the same as the function f of x. But it should be something similar unless it's far away from the x value we created the tangent line at. Okay, so that's what we're going to be doing. We're going to be finding that equation of a tangent line just like we were yesterday, and we're going to be using that equation to estimate the value of the f of x function. Okay, let's get started. First up, let's do a warm-up here. This is a question they kind of like to ask on free responses and maybe on multiple choice. So a function f of x has a property that the derivative is greater than 0. And let's just remind ourselves what that means. Derivative greater than 0, that means that the function is increasing because it has a positive slope, right? And the second derivative is less than 0. Okay, let's remind ourselves what that means. That means a second derivative tells us about concavity. It's less than 0, so that must mean that it's concave down, right? If you use an equation of a tangent line to the function to approximate a value of f of x, the approximation would be less than f of x, same as f of x, or greater than f of x. Okay, well, let's think about this. If we have a concave down function and it's increasing, so we're just focusing on the first half of this. So we have a function that looks like this. It's concave down and increasing. And we use a equation of a tangent line to approximate this. So, I mean, you can put this tangent line anywhere you want. Let's say it's right here. It means it touches it at just one point, right? It's my tangent line. If I use that tangent line to approximate our original function anywhere, would it be less than f of x, the same as f of x, or greater than f of x? Well, it's going to be greater than f of x everywhere except for the actual point at which we evaluated the tangent line. So the answer here is greater than f of x. If we're using this line to approximate this function, f of x, then our equation is going to approximate everything greater than. And notice, so this is going to be true for anything that's concave down. It doesn't need to be increasing. If you use the decreasing half, look at every value on that line is greater than the function. Now look if you have a concave up function. If you do an equation of a tangent line there, everything on that line is less than the function. So if we have a function that is concave down, then we know all our approximations are going to be greater than the original function. Concave up would be less than the function. So you might want to write that down. Concave down approximation, or let's put a linear approximations. Linear approximations are greater than f of x. Okay, and write the exact same thing for concave up, except so it would be concave up linear approximations are less than f of x. Okay, now I have a free response here that we're just going to walk through, and then we'll be done with this PowerPoint. So let's read through this. A function r of t measures the number of people that have entered the auditorium, where r of t is measured in hundreds of people and t is measured in hours. Okay, so this is telling me hundreds of people, and this is how many hours that have passed. Okay, find r prime of t of pi over 3 and use the correct units. Okay, so we need to take the derivative of this. Okay, so the derivative of this is going to be with chain rule, first of all. Yeah, and the derivative of secant is tangent. So r prime of, and I'm just going to write r prime of t equals, okay, so it's going to be chain rule, right? And you know what? I just remembered here. Secant, the derivative of secant is not tangent, it's secant tangent. Yeah, it's both of them. So it's secant of tangent of, and remember, what goes in here is the same thing that was inside of there. And remember, it's chain rule, so you're going to multiply by the derivative of the inside, which is just 2. Okay, there's my derivative, and I want to evaluate it at pi over 3. So let's do this. And I didn't really leave myself too much room, so I'll do it up here. R prime of pi over 3. Okay, so it's going to be secant of, okay, now if we plug in pi over 3 for this, that makes it 2 pi over 3. So we got 2 pi over 3. Tangent of, and we got the same thing, 2 pi over 3. It's all multiplied with 2. Okay, let's evaluate what all these are. Okay, remember, if you see secant, that is writing 2 over square root. If you see tangent, that's the same as writing square root over square root. And then I'll just turn this into a fraction since I'm going to have fractions. 2 over 1. Okay, pi over 3. Remember, that is your index finger, so you put your index finger down. Secant is the same as cosine, so there's going to be 1 finger up, just your thumb. Okay, same thing over here. You put your pi over 3 down, and it's going to be, tangent is the same as sine over cosine, which there are 3 sines and 1 cosine. Okay, now let's just check what quadrant these are in. Okay, so all students take calculus. Okay, this is going to be in the second quadrant because it is 1 less than the denominator. So sine is positive. This is not a sine, so it's going to be negative. Tangent is not a sine, so it's going to be negative. Okay, so now let's just multiply across. The bottom is going to become 1. So I don't even need to write anything. The top is going to be, I'll multiply that and that, so it's going to be the negative and the negative make a positive, so it's going to be just 4 square root of 3. That's going to be our answer. Now, it did say to use correct units. That is something that a lot of people forget to do. Okay, there's my value. So here, let's write out our answer here. 4 pi over 3. And then let's use correct units here. This is the derivative, which means we are doing slope. So y, rise divided by run. Hundreds of people per hour. So hundreds of people per hour. So if it asked you to explain the meaning of this, that would mean at the time, pi over 3 hours, okay? And you could actually figure out what that is. That's going to be around 1, right? So around 1 hour, there is going to be 4 square root of 3, which if you wanted to write that as decimal, you could. Hundreds of people per hour entering the auditorium. Yeah, that's what that's going to mean. Because a lot of times they like to ask you, explain the meaning of this. Okay? Okay, so find the equation of the tangent line at pi over 3. Okay, well, remember, if you see the words find the equation, you know exactly what to write. Y minus y1, I'm going to leave a blank, equals m, I'm going to leave a blank, x minus x1. I'm gonna leave it blank because those are the three things I gotta fill out, right? Okay, remember they need to give me one of the things. Now in this case, I just realized I messed up. I put an X when it really should be a T. Yeah, because they're not using X's, they're using T's, and they're not using Y's, they're actually using R of T. So we could just put a giant R there. So really what this should look like more correctly here is R of T minus something equals blank T minus blank. Okay. Notice they gave me pi over 3. That is my T value. That's going to be like my X value. They gave me something. Now with that, I should be able to find the slope and the Y value. Well, look at this. On the previous one, and they like to do this on the test, they asked us to find R prime of pi over 3, which is exactly my slope at pi over 3. So I already know this right here is 4 square root of 3. I got my slope. Now all I need to figure out is my Y value, my number of people at that point. So all I need to do is R of pi over 3. I just need to plug it into the function. So that's going to be secant of 2 pi over 3. And that is the same as, remember, 2 over square root. Pi over 3 is your index finger. That leaves one cosine down, and it's in the second quadrant, which makes it negative. So negative 2 is my Y value, which a negative and a negative makes a positive. So our equation of tangent line, let's just subtract that over, and we got our answer. R of T is equal to 4 square root of 3 T minus pi over 3 minus 2. Okay, that is the equation of my tangent line. Now that is just an approximation, right? It's going to find values. It's probably going to ask you, after you do these, it's probably going to ask you to use it to approximate something. So like here's the question it's going to ask, using the tangent line at pi over 3, which we have right here, approximate the number of people in the auditorium at t equals 1. Okay, well I just need to plug in 1 there. Okay, so let's just do that. R of 1 equals, okay, so it's going to be 4 pi over 3, 1 minus pi over 3, minus 2. And you can kind of simplify this a bit if you'd like. Let's find a common denominator here. So we're going to have 4 square root of 3, 3 over 3. I'm switching the 1 to be 3 over 3, minus pi over 3, minus 2. Okay, we can combine those, so it'll be 4 square root of 3, 3 minus pi on top, all over 3, minus 2. And I mean, you could distribute that to both the 3 and the pi. I'm just going to leave it like that. That is my approximation. That's my number of people in hundreds, number of people. That's my approximation for the number of people in there at time 1 hour. And if it asks you to figure out if it's an over or under approximation, remember you would want to find the second derivative of this. You would plug in pi over 3 to see if it's concave up or down. Yeah, if it's positive, it'd be concave up. If it's negative, it would be concave down. And in this case, it doesn't ask us to do that, so I'm not going to do it. But that's how you would go about figuring out if it's an over or an under approximation. That's everything.